we're going to talk about our last pavement system, the grid system, and we're going to focus on plastic grid systems. Two main classes, gravel and grass. Lots of different uses other than stormwater. An example of a trail system. There's lots of different types of uses, horse stalls, all kinds of things. Stormwater and reducing impervious surface uses, there's lots of different applications. Trails, utility access, low-speed roads, driveways, very typical. We'll start off with the gravel systems. And I'm going to use, just because it's easy, use the invisible structure system just as an example. Okay, there's a lot of different products, and you need to consider your particular application for the right product. But you can see a long list here of different products. Just as we've talked about on the other products, a specific base material, not necessarily a choking material like on the other pavers. This is an old slide, and it's purposefully an old slide, actually off of the Invisible Structure website, and it gives you a gradation for their base material, typical sandy road base type material. Look at the drawing, and so if, you go on site, you're thinking about using a system like this, and you go on site and you see this drawing and you look through it. Any red flags, anything interesting that pops out, calling out for 95% compaction on your subgrade, that makes you wonder, what do you do? I get on the horn with the vendor and say, well, is that right? Well, in fact, Invisible Structures doesn't really call that out anymore. And you can use these systems on a subgrade that's not at that compaction effort. So you have a lot of resources at your disposal for these products, like the pavers, and certainly these grid systems. And so there's a lot of resources that you can draw from, and you'd want to get on the horn right away and say, hey, what's going on with this? How do we make this work? Does this work? For an infiltration system. Again, lots of different products. There's nuance to these systems, the grid colors to match the aggregate, for aesthetics. Lots of different systems, as we've mentioned. Lots of these systems use recycled material, and they have different structural characteristics. And you can imagine looking at that invisible structure versus that grassy paver. One's very rigid, the other is really flexible. One, the invisible structures comes in a big roll. Actually, I've seen pictures of people with that stuff on their back, hauling it into a trail somewhere. So lots of different structural characteristics and handling characteristics. Just as we've talked about with all these other materials, the filler for the gravel, the wearing course, what? We've seen this how many times now? Clean, angular, hard, and uniform. There's lots of different products you can use, colors, but you're going to be in this range of sort of 3/16 to 3/8. You don't want a round rock. Again, just using invisible structures, their gravel pave system is one example, and I just want to make sure this is not an advertisement for invisible structures by any means. It's just there's so many of these things. We're going to use one as an example. Pretty easy installation. All the same considerations for your subgrade. How do you manage that subgrade to retain that infiltration capability, but get a uniform subgrade surface to work from? Same processes, like using in your excavation, that process backing out of the system, not driving on the finished subgrade, back dumping your aggregate so you're not driving directly on the surface of the subgrade. All those same considerations. In this case, you're looking at an installation sequence using a small compaction machine. Same considerations. You want this stuff. Geotechs use the term firm and unyielding, and that's something you can describe, compacting that base. Rolling the stuff out. This product over on the far right, you're securing the material down with the pins. And this is probably, for invisible structures, the place where you see the most problems, in that contractors, they tend to forget. I'm not sure if that's the right term. Whatever, they tend to not put these pins in, particularly in edges where you should be putting more pins, and there's recommendation for that pin frequency. So this is where we've seen quite a bit of problems, and where they had this sort of torquing and lifting up of the material at High Point in West Seattle. On further inspection, there were no pins in the system. And so, there's an obvious installation problem. And you can see you want to fill and either, broom out, spread out that aggregate, and then you're ready to go. So that's a nice advantage of these systems, is that you install and you're ready to go. You want to maintain that aggregate just above the rim of the plastic grid. That can be challenging. Otherwise, it's exposed to a lot more wear and tear, if not. But that's the recommendation, and would be one of your maintenance considerations. The grid systems, again, using invisible structure, the gravel pave, have considered the the ADA access issue, and there's really not a such thing as certified, ADA, but there are criteria. And so, for example, these properly installed and maintained, these systems can be used in an ADA setting.
With grass, it's pretty much the same principle. Instead of filling the cells with an open graded aggregate, we're filling it with planting medium, some really sandy soil. I typically amend that sandy soil with an amendment, a diatomaceous earth, to really increase the water holding capacity of that soil, because one of the things that happens if these things are designed well at all is they're very well draining. And so what happens is the grass just has a really hard time staying green during the summer. And we don't really want to obviously, have to have too much supplemental irrigation. So putting a little bit of soil amendment in the planting soil just really goes a long way to helping it maintain how it looks. And its application, unlike the gravel, which can be, of course, used without hesitation and without any real impact, more or less, to the system, grass not so much. If we want the grass to maintain a uniform green carpet, we cannot drive on it every day. It's not that the system stops working hydraulically. It really continues to maintain its stormwater function, and it probably actually continues to maintain its firmness in terms of being a firm surface. It's just that the grass dies and wears out. And so if you're willing to tolerate that, what is essentially mostly an aesthetic issue, then that's okay. And overflow parking is ideal. Fire access is ideal. Access for infrequent utility maintenance is ideal. Residential driveways, it depends. Maybe for an outer parking, overflow parking area, but for your main driveway that you're going to drive on every day, if you're going to put in grass, then you should expect it to probably wear out. And pedestrian traffic, again, if it's infrequent pedestrian traffic, for example, I think we'll see a picture coming up of a farmer's market. That happens in the summer and the foot traffic is infrequent, that's okay. With all of these permeable systems are generally able to achieve whatever structural load is required. That's not an issue with these systems. It's just a question of building up the section to get, whether it's the case of an outrigger, as we're seeing here in the image, or wheel load, or what have you. So in a lot of these systems, in grass paving in particular, I've often used a geogrid. Setting a geogrid down at the bottom of the section goes a long way to getting the kind of wheel load, point load that you want to achieve. There's a range of manufacturers out there with different shapes, variations on a theme. These are some of the manufacturers that are available. Again, they have different rigidity, different recycled content, different looks, different shapes. Different stiffnesses. So this is the similar slide as earlier. It's a similar base as with the gravel applications. It's almost identical of an application, except instead of filling the cells with open graded gravel, we're filling it with sandy loam with grass planted in it. The systems can easily meet H20 and other loading if you utilize engineering design practices by building up the section that you need to achieve that. So we mentioned earlier that the fill material in the grass application it's a nice sandy loam. The grass paving, the soil that I use is essentially bioretention soil mix, 60-40 blend, amended with this moisture holding admixture amendment, and that's essentially the mix that I've used, and that seemed to work really well. So this is the example. The drawing there is showing a different product, showing the grassy pavers product, but it's showing how you've got a kind of a finer grained soil. In the manufacturer's image here, I'm not so sure how that really sandy material is going to sit on top of that open graded material, but in the cases where I have used this, I've not had a reservoir course like this manufacturer is showing, but instead have had more of like a coarse sand section that allows the grass roots to grow down into that section, but also maintain some good structural capacity and infiltration capacity. So again, it's going to be a similar sequence of construction, you can imagine, where we're putting down our base. If we need to add some sort of fertilizer, proceed with caution on that. But anyway, we put down and then we unroll or place our pavers and then backfill with our sandy loam and then generally seed it. That's how it works. And then, of course, obviously, we use it. And this next image here, this is the fire lane design for the Suquamish Community House. Not only shows the kind of structural section, I think it's a particularly elegant solution to combine the gravel and the grass fill into one system. So you can see the triaxial geogrid that I've got down at the bottom of the section. I fill with like a coarse medium sand, and that's my road section. And then there's the plastic grid system, and I fill the outer 4 feet on either side. That outer 4 feet is filled with the grass, and then the inner 12 feet is filled with gravel. The goal here was to create 20-foot fire access, but we really wanted to discourage everyday traffic from coming onto this lane because of the site configuration, though we wanted this lane to be used for the drop-off of elders who are coming to tribal events. So I think this idea of the aesthetic considerations of the design, I think really shown in this case. We were able to come up with something that was fully permeable, met the fire department's need for full 20-foot access, but then met the tribe's need for really to try and de-emphasize this road, because had we built this out as a 20-foot road, it would have been a lot more traffic would have come down this road than they would have liked. So I think it really met multiple goals, and I thought it was a pretty cool design response. We mentioned snow removal earlier. Those issues that we discussed are probably even more apparent here with grass. I'm not sure if I would attempt to plow a reinforced grass section, but I think probably letting that be would probably be the course of the day. The grid systems and the reinforced grass cell systems also have the huge advantage of addressing urban heat island effect, in addition to porosity and site coverage and all of these other benefits. By having a pavement that's essentially grass, that's going to address the urban heat island issue with a relatively low reflectance rates. When it comes to lead, we haven't really talked too much about lead specifically with the other systems, but any one of these permeable paving systems can achieve various degrees on lead points, and certainly grass paving can get quite a bit, especially if it's non-irrigated.